As the world slowly transitions to greener forms of power generation to combat dwindling natural resources and the dangers of climate change, one less fashionable route to easing this transition is to make better use of the energy we already produce. Staggeringly, 67% of all energy produced is wasted, 90% of which comes in the form of waste heat. This represents a huge untapped resource of approximately 106,000 terawatt-hours each year. Converting just 1% of this energy into electricity would provide sufficient power for the needs of Spain, France, and the United Kingdom combined. Thermoelectrics is a technology which converts a heat differential directly into electricity. When one side is hot and the other is cold, a current is generated. The nature of thermoelectric generators allows system designers to access the heat in ways that wouldn't be possible with standard technologies. The science of thermoelectric power generation, the so-called Seebeck effect, has been understood for 200 years. But, despite plenty of promise, low efficiencies, high costs, and an inability to operate at high temperatures have restricted its use to niche applications, until now. MicroPower Global has spent the last 10 years addressing the deficiencies of thermoelectrics and advancing the technology to a stage where it is ready to tackle large-scale, high-temperature industrial applications. Working in world-class facilities at Star One near Austin with the help of Texas State University, MicroPower has focused on several key areas. The first is a proprietary method of producing thermoelectric material that provides a far better starting point in terms of its energy density. The second area is a patented barrier layer applied to the material on an atomic level, which provides a significant boost to its efficiency. The third key area is the development of high-temperature interconnect structures that enable MicroPower's devices to handle extreme temperatures, well above 1,000 degrees centigrade, and extreme circumstances, such as direct contact with flames. However, none of these advances would be of any use if the costs were prohibitive. But thanks to a relatively straightforward semiconductor manufacturing process, inexpensive materials, and minimal operating and maintenance costs, once manufacturing at scale, MicroPower's devices can achieve a levelized cost of electricity of 2 cents per kilowatt hour, cheaper than virtually any other form of power generation. As the company moves to complete its first production line with pilot projects in the steel, power generation, and glass industries, there is growing excitement spanning a multitude of different applications. Anyone that has heat available above 300 degrees centigrade and isn't currently making good use of it is a potential partner. But MicroPower's devices don't only run off heat that is the byproduct of another process. There are several ongoing initiatives to develop products that deliver off-grid portable power, with potential applications from emergency services and security through to emerging economies. With a breakthrough in performance that has been over 10 years in the making, MicroPower is now well positioned to realize the dream of delivering clean, affordable power from waste heat in a variety of different sectors, helping partners save costs, become more energy efficient, and reduce their carbon footprint. Please contact us to find out more.